Hi, welcome back. Today we're going to talk about systems of equations. We are specifically going to be looking at nonlinear equations. So our first example, it has a y equals x squared plus 4. So that is a parabola. And then the second equation is a line. So we have at most two solutions. Now, it might also be a tangent line to get one solution, or it might be a line that doesn't intersect the parabola at all and we get no solutions. But 2 is the maximum. So let's see how this works. We're going to start with the substitution method. So I'm going to plug this value in for y. So I take my second equation and I get negative 2x plus my y becomes x squared plus 4. Equals 1. Okay, so then I can just rewrite this quadratic in standard order. And I can subtract the 1. And I'll get x squared minus 2x equals 0. This quadratic factors nicely to x minus 3 and x plus 1. You could also use the quadratic formula if you find that necessary. And then I can take each piece, each factor, and I get two solutions at x equals 3 and x equals negative 1. Now each of these x values is going to correspond to a y based on the formula x squared plus 4 that we started with up here. So I get y equals 13 when x is 3. And when I put the negative 1 in, negative 1 squared becomes 1, so I get y equals 5. Okay, so my solution needs to be written as ordered pairs so that I pair the y to its corresponding x value. Okay, all right, let's try another one. In this example, I also have a line, and then this second equation makes a circle. So if I have a circle, I could have a tangent line and get one solution, or a line that never intersects it, or a line that intersects it twice. So I have a maximum of 2 solutions. And again, we're going to use substitution. This first equation tells me x equals 3 minus 2y. Simply subtract the 2y from both sides. And that makes the second equation my x squared plus y minus 1 squared equals 2. Now I'm going to FOIL each of these things out. That means I'm doing 3 minus 2y times itself. Okay, and so we end up with 9. The outside and the inside are both minus 6y. And then the last piece is plus 4y squared. Okay. The second one, when I do y minus 1 times y minus 1, I'll get y squared. The outside and the inside are both negative y, so I get minus 2y. And then the last is plus 1. Okay, so now let's combine like terms. So I get 5y squared. I get negative 14y plus 10 equals 2. Subtracting the 2 to the other side gives me 5y squared minus 14y plus 8. And now I'm going to use the quadratic formula on this one. So I'm going to have negative b, which becomes 14, plus or minus the square root of b squared minus 4 times a times c, all over 2a. If you don't remember the quadratic formula, it looks like this. okay, where this is A, B, and C. Okay, so now we calculate this. 14 squared is 196. 4 times 5 times 8 gives me 160. So I end up with 14 plus or minus the square root of 36. And the square root of 36 is 6. So I have 14 plus 6. And I have 14 minus 6. So my x values are 2 and 4/5. Now I have to find y for each of those. Okay, excuse me, this is y. So I have to find x for each of those. So if y is 2, then x is 3 minus 2y, which is going to equal -1. If y is 4/5, then x is 3 minus 2 times 4/5. So that's 3 minus 8/5. 3 would be 15/5. So I get 7/5. So my solution, again, we're going to write the ordered pairs, and ordered pairs are always x comma y. So we have -1, 2, and 7/5, 4/5. So it is okay to get fractions. You can graph these systems just like our linear systems and get the solutions, but again, if they're fractions, it's going to be hard to spot them precisely. All right, let's do one more here. Now in this one, we have x squared, we have y squareds in both, so I can actually use elimination. If I tried to solve for x, I'd end up with a square root, so that might get a little messy. So we're going to eliminate. So I'm going to pick y to eliminate. So I notice I need both of the coefficients to match. So the quickest way to do that is to make this bottom one a 3. So I'm going to multiply the bottom equation by 3. Okay, the top equation stays left alone. Okay, and then we add. So I get 5x squared. The y's go to 0, and then I get equals 20. Okay, now we divide by 5, and I'll get x squared equals 4. So that makes x equal plus or minus 2. Okay, so if x is 2, then using this second equation, I'll get 2 squared minus y squared equals 3. So 4 minus y squared equals 3. So that would tell me if I move the 4 over, I'll get -y squared equals -1. And I end up with y equaling plus or minus 1. So far I have 2 points. I have 2, 1, and 2, -1. Now let's let x equal -2. Well, interestingly enough, it's going to end up doing exactly the same thing, because when I square a -2, I still get 4. And so I'm going to still end up with y squared equals 1, and I get the same 2 answers. Okay, so then I have -2, 1, and -2, -1. So I have 4 solutions. Now we want to be real careful to make sure we write all 4. So for instance, we may feel like we want to do this. But the question is that 2 solutions or 4? Like, I'm not real sure if I just mean the 2 with both plus and minus 1, and then the -2 with plus and minus 1, and I get 4, or if I just mean 2 and 1 and -2 and -1 and get 2 solutions. So it's a little ambiguous. So we want to be sure we make sure it's all 4. If you must write it simpler, then I would do it as, 2 with plus or minus 1 and then negative 2 with plus or minus 1, because it is clear that that's going to be 4 points. Okay, but make sure we give the answer as all 4. Now, just so you know graphically, the first equation is an ellipse. The second equation is a hyperbola. And so we have 4 solutions. Okay, and you'll get more of that when you do a unit on conic sections. All right, so here's an application of this. So we have a rectangle. We'll call it X and Y. And then its perimeter is 10 feet. So the perimeter would be 2x plus 2y equals 10. Okay, that's the distance all the way around. Its area would be x times y, and that's going to equal 6. Because this x and y are multiplied, I cannot do elimination. So we're going to do substitution by making this x equal 6 over y. That makes this first equation 2 times 6 over y plus 2y equals 10. So I end up with a rational equation. And so we solve rational equations by multiplying by the least common denominator. Well, in this case, that denominator is just y. So I get 12 over y times y. I get 2y times y, and I get 10 times y. So these cancel. If I subtract the 10y over, I get 2y squared minus 10y plus 12 equals 0. And then I can factor out a 2 to make the numbers smaller. This one factors. Okay. The 2 will just divide out. And so what I'm left with is y minus 2 equals 0 and y minus 3 equals 0. So y is either 2 or 3. Now if y is 2, I have x equals 6 over 2, which is 3. And if y is 3, then I get x equals 6 over 3, which is 2. So I'm just switching places with the length and the width. So my dimensions are 2 feet by 3 feet. In this case, I don't need it as ordered pairs. I want to put units on it. Okay, last one. We now still have a rectangular box, or actually it's a piece of cardboard, and it is x by y, and the area is equal to 216 centimeters squared. Okay, now then we're going to cut squares out of the corners. In doing so, I can fold this up, and what I end up with is a box with a height of 2. Now, what is the length and width of the box? Well, if this square that we cut out is 2, then this new width is x minus 4. And if it's a square of 2, then the y is also going to be affected by it and be y minus 4. So the volume is going to be 2 times x minus 4 times y minus 4. Okay, now if we FOIL that out, we'll get 2 times xy minus 4x minus 4y plus 16. We can also divide by 2, and we get our equation equal to 112. Now our area equation here tells me that x is 216 over y. So if I plug that in here for y, we're doing for x. If I plug this in for x, then what I end up with is 216 over y times y minus 4 times 216 over y minus 4y plus 16 equals 112. Now I can reduce a little bit. The y's go away. So I have 216 plus 16, so that gets me 232, minus 4 times 216 is going to give me 864, okay, over y, minus 4y equals 112. Okay, now I can move the 112 over, and what I end up with is 120 minus 864 over y minus 4y equals 0. And now this rational equation, I'm going to multiply the whole thing by y. Okay. Now I need to solve this. I can use the quadratic formula. I do notice that they're all divisible by 4. I also notice that I might want to rearrange them. So I'm going to put negative 4y squared out front. And so I'll get y squared minus 30y plus 864 divided by 4 is going to get me 216. And now I can use the quadratic formula. So I'll have 30 plus or minus the square root. 30 squared is 900 minus 4 times 1 times 216 over 2. Now we already said that 216 times 4 is 864. So if I have 900 minus 864, what I really end up with is the square root of 36. And that's 6. So I have 36 over 2, and I have 24 over 2. So I end up with 18 and 12. Okay, now putting those in here, I'll get 216 over 12, and I'll get 216 over 18, which is just 18 and 12. So the dimensions of the cardboard to begin with, the x is 12 and the y is 18, or vice versa. So the dimensions are 12 centimeters by 18 centimeters. Okay. All right, so hopefully that helps you see a little bit about how systems of equations can be done even when the equations are not linear. Gives you a couple of application questions. If you have questions that you'd like me to answer, please comment below. And if you're in class with me, we will see you on Friday. But please go ahead and take a look at that last example. See if you can on the worksheets right here, and see if you can do it on your own, and we'll check it in class. All right. See you next time. Bye.